Hi everyone, my name is Hannah Bonner and I work with the Utah Division of Water Quality. And this is a review for our HAB Squad volunteers, both new and continuing, and also a great source of information for people who are interested about understanding harmful algal blooms in Utah. Today I'm going to touch on a few different topics. First of all, I just want to talk about the basics of harmful algal blooms. What is a bloom? Why do they form? Why we worry about them? And then really key to your responsibilities as a HAB Squad volunteer, how do you identify a bloom? From there, I then want to talk about how you can help us in interfacing with our statewide monitoring program and helping track water body conditions and protect water body conditions of water bodies near you. So to begin with, I just want to get us on the same page with terminology. I'm mainly going to be using harmful algal bloom or HAB as I talk about these events. But you might have also heard them described as cyanohabs, HCBs, blue-green algae, toxic algae, or probably most scientifically accurate, cyanobacteria or cyanobacteria blooms. These are all the same thing, and they are caused by certain species of toxin-producing cyanobacteria. Cyanobacteria, or this harmful algae, is actually present in low levels in pretty much every water body in the world. For example, this is a photo of Utah Lake, and it's not experiencing a HAB right now. We collected a sample, and we were seeing really low levels of cyanobacteria, so tens of cells per milliliter. However, there's a few things, many of them human-related, which can facilitate the formation of a harmful algal bloom. First of all, because cyanobacteria is a photosynthesizing bacteria, it really likes hot, sunny days. And so as water bodies tend to get warmer, as we're getting more sunlight, so summer, fall, that may precede the formation of a bloom. The other thing that really helps facilitate a bloom is nutrient pollution. This is nitrogen and phosphorus, and nutrients are required for rapid multiplication of cyanobacteria, which can facilitate those bloom conditions. Nutrient pollution especially is oftentimes related to human activities. Some common sources are listed here. So everything from the water that holds our sewage and gets discharged into water bodies, to runoff from our cities and towns and industrial areas, to livestock and agriculture, to just the way we manage erosion, roadways, and habitats around water bodies. All of these can introduce that nitrogen and phosphorus, which feeds blooms. There's also things we each do in our own individual lives that results in nutrients flowing downstream. For example, how much fertilizer you put on your yard or garden, clogged storm drains, if you have lots of leaves in your gutters, leaky septic systems, and even some products we use. Many detergents and soaps have high levels of phosphorus. And then even little things like not picking up pet waste. Again, all flows downstream and can elevate nutrients in whatever the nearest water body is. These things in combination really create ideal conditions for a harmful algal bloom to form. So for example, here's that exact same site, but it's now experiencing a harmful algal bloom. And when we collected a sample, we were seeing cyanobacteria in the millions of cells per milliliter. Cyanobacteria is now dominating this system and crowding out other beneficial phytoplankton. And so this is an issue for a variety of reasons. First of all, what I just said, cyanobacteria has taken over this ecosystem, which means it's crowding out other beneficial species. It's altering the balance of the water body, and this can be harmful both to species small and large. As well, many species of cyanobacteria have the ability to produce dangerous toxins, which can hurt both humans and animals. I have some examples here. First of all, just exposure to the cyanobacteria cells themselves often will cause gastrointestinal illness, so vomiting, diarrhea, stomachache. And then those toxins can do anything from targeting the liver to actually shutting down the neurologic system. So some pretty severe health effects or even death are possible from high enough exposure to cyanotoxins. So the third reason for both those first two reasons, harmful algal blooms not only hurt the environment, but they also hurt local economies and the ability for people to be able to recreate and enjoy Utah water bodies. Unfortunately, we're also seeing more and more water bodies in Utah experiencing harmful algal blooms, particularly as we deal with a warming climate and continued human development and nutrient pollution. This graph shows the number of water bodies in Utah with a harmful algal bloom each season since we started monitoring, and you'll see there is a pretty distinct upward trend. So, what does this mean for you as someone who loves and wants to enjoy Utah waters? We're going to talk a little bit more about these things in detail, but first of all, I just really want to emphasize how important it is to be informed and educated, something you're doing right now, and that you can continually keep up to date with water body conditions around the state by visiting our website, habs.utah.gov. That lets you be able to know what to expect when you're visiting a water body. And when you combine that with your own ability to identify a harmful algal bloom, you can really make sure to keep yourself, kids, and pets safe. Obviously, if you see a bloom, you don't want to be swimming or playing in that water, nor do you even want to be boating, jet skiing, or tubing because you can actually aerosolize or throw up those toxins if there's a thick surface scum present. And then, like I mentioned earlier, children and pets are most vulnerable from these events, and so we always recommend keeping them away from areas experiencing a HAB. And then, of course, as you're here today as part of our HAB squad, making sure that you know how to recognize a bloom, and then if it's something we're not aware of on a statewide level, taking photos and reporting it is so useful in keeping other people safe. So from there, I want to talk about how do you recognize a bloom? How do you know if what you're seeing is cyanobacteria? This photo right here is a pretty dramatic example. Cyanobacteria has this special pigment called phycocyanin that when the cells die and break open, they can leak out into the surrounding environment. So sometimes it can have this really distinct green, blue-green color. And as you'll see in this picture, when you have thick accumulations of cyanobacteria or large-scale blooms, you actually often will get a scum on the surface. So the cyanobacteria is dispersed throughout the water column, but the dead cells are really accumulating here, forming that film. There can be a wide variety of appearances, though, when it comes to these blooms. The image on the left is another really dramatic one. Once again, you're seeing that bright blue-green color and a really distinct surface scum. But sometimes this can be a lot more subtle. The images on the right show more of a green color. The top right, there is again a surface scum. In the bottom photos, the cyanobacteria is more dispersed throughout the water column and manifesting either as green globs, as in the bottom right photo, or in that bottom right left photo, cyanobacteria can also look like grass clippings. I've seen sites where it almost looks like someone mowed their lawn and then dumped their bag of grass clippings into the lake. So that can be another form. And really a good rule of thumb is if you're seeing green shapes floating in a water body, there's a good chance it's cyanobacteria. A few more photos for you. Here again, we see cyanobacteria dispersed throughout the water column here on the left. In this top right image, we actually see a bathtub ring of that blue pigment. This can be common. This is a pretty dramatic example, but sometimes you might even just see a faint line along the shore. And then here in the bottom right, once again, we have those little green globules of a bloom. That being said, we've seen a few different ways cyanobacteria can look. There are two common imposters we see here in Utah that folks often confuse with cyanobacteria. So I want to talk about these so you know what not to worry about. The first Cyanobacteria look-alike is duckweed or other aquatic plants. Here's some photos of what this looks like. And you can see here on the left, this could easily be mistaken as a bloom from a distance. But once you look a little bit closer, you're actually going to distinctly see leaves and roots. And so it's really easy to tell duckweed apart from a harmful algal bloom, because if you see roots or leaves, you know it is not cyanobacteria, it is not a harmful algal bloom, it's not a problem for the water body. So that's how you first tell apart this imposter. The second imposter that people oftentimes confuse for a harmful algal bloom is filamentous green algae. Here's an image of filamentous green algae, and you can see this one is a little bit tricky. It seems to be forming a surface gum. It has that green kind of goopy texture. However, luckily there's a nice trick for telling apart filamentous green algae from most types of harmful algae. It's what we call the stick test. And it takes advantage of the fact that filamentous green algae has a really distinct, fibrous, hair-like texture. So I'm going to show you a video of the stick test. And just like it sounds, you basically are going to find a stick or some other object that's not your bare finger and use it to explore the texture of what you're seeing. So let's start this video. Okay, I'm going to pause it for a minute. And as you saw, the person in this video found a stick, pulled out the material, and the material they were seeing was really fibrous, hair-like. You could see those little filaments hanging down and dangling. I'm going to switch now to my next slide that has a static picture. Again, stick, that very fibrous, stretched out hair-like texture. Here's a close-up of filamentous green algae where you can see that again. This is really characteristic of this filamentous algae, and it's a really good sign if you see this. Filamentous algae does not produce toxins and does not constitute a harmful algal bloom. So the stick test is a powerful way to distinguish the two. And really, when it comes down to it, my recommendation is when you're wondering if something is a harmful algal bloom, you get to a water body and you're seeing something weird, green to blue-green to brown in the water body, rule out, is it duckweed, an aquatic plant? Is it filamentous green algae? And if the answer to both those questions are no, it's best to assume whatever you're seeing is a harmful algal bloom and to proceed with caution and let us know if it's not something the state is aware of. One caveat to that, thus far we've been talking about and looking at photos of planktonic harmful algal blooms, which we usually find in standing water like our lakes, reservoirs, and ponds. Another emerging issue in this state is benthic cyanobacteria, or harmful algae mats, that can actually grow in both standing and flowing water. So we see them in both lakes and also streams and rivers. And these harmful algae mats or benthic cyanobacteria are a little bit tricky because they look not quite as obvious as our harmful algal blooms. Let me show you a few pictures. As the name suggests, these harmful algae mats grow as a mat or a coating on rocks, sand, aquatic plants, and are quite gelatinous and viscous in texture. So I'm holding one in this picture here. You can see that really goopy, mucousy texture, and then the same kind of mat attached to rocks in this area of flowing water. These mats can vary widely in color and texture. Here's another example of a mat submerged on a rock in another river in Utah. And this one, again, you can imagine it's several centimeters thick and has a really brown, veiny texture. And then, like I mentioned, these are also found in standing water. So this is a cyanobacteria harmful algae mat. It's actually detached from the bottom of the lake and floated up on the shoreline. And again, it has that really goopy texture. So the best way to distinguish these harmful algae mats is actually quite similar to a harmful algal bloom. Once you know this is something to be looking out for, if you're seeing anything that's green, brown, tan attached to substrate in a water body, rule out that it's not an aquatic plant. Rule out that it's not filamentous green algae, so it's not hair-like or really fibrous. You can use a stick test again. And if you've ruled out both those possibilities, then assume any mucousy mat you're seeing is benthic cyanobacteria. And again, take some photos, let us know, keep kids and dogs away. Okay, so hopefully now you feel confident about identifying these sort of materials, these kind of blooms and harmful algae when you're out and about. I also will throw out, if you go to our website, habs.utah.gov, We have a photo library with even more pictures about what these events look like around the state, so you can practice or compare with something you might be seeing as you're out there. And really, like I've mentioned, we need your help. Utah has a couple thousand water bodies, and it just isn't feasible for our team to be able to monitor them all the time. And so we really rely on volunteers and an informed public like you to help us catch these events as soon as possible and be able to keep other people safe. What we do as a state is we have about 20 water bodies that we know are at high risk for the formation of a harmful algal bloom. That's what this list is here. And we visit these water bodies at least monthly, May through the end of October, looking proactively for a bloom. And if we are starting to see something suspicious, we increase that frequency to weekly. So these water bodies we're highly aware of, but like I mentioned, there's a lot of other water bodies that we still want people to be keeping eyes on. Everything we know so far is posted to that website, habs.utah.gov. We have an interactive map I'm showing here on the left, and we also share updates about when we last visited, what we were seeing, what sampling results showed. And so like I was saying earlier, making some time to check this website before you go to a water body is really powerful, so you can know if a known issue is present. And as well, as a HAB Squad volunteer, if you visit a water body and are seeing evidence of harmful algae, before you notify us, take a look at this website and make sure it's not something we're already aware of. We love your involvement and awareness, but if it's something we already know about, there's a lot less urgency than if it's a new issue that hasn't gotten on the state's radar yet. On that note, if that is the case, if you go to a water body, see something suspicious, have done the stick test, ruled out aquatic plants, checked on the website, and think you might have discovered a bloom that's just developed, we want to know as soon as possible. And that really is one of the key roles and values of the HAB Squad, is you allow us to keep tabs on these sites rapidly to proactively and make us intuitively and intelligently prioritize where we're going to visit. So just aside, if you're just right now exploring the idea of the HAB Squad or aren't sure what it is, I've put the link here to USU's page. Please take a look and consider signing up. If you do find a HAB, like I mentioned, you know how to recognize it, you're familiar with Utah resources. The other things that are really helpful is taking good photos. That allows us to understand what you're seeing and be able to visually assess the situation. And then also collecting really specific location information anytime you see something suspicious. I have an example here from 2023. This was a report we received about a possible harmful algal bloom at Deer Creek Reservoir. And as you can see, the reporting party shared a variety of photos. They did a broader landscape photo, which is really helpful for us to understand the scale of what you're seeing. So in this case, we could show you that, oh, wow, there's green harmful algal material widespread in this bay, forming both a surface scum, and it looks like it's in the water column as well. And then they also shared several close-up photos, which are also very important so that we can really confirm that what we're seeing looks like harmful algae. In this case, we could see, oh, wow, there's these accumulating green globules, both on the surface and in the water column. And then, like I mentioned, specific location information is really key. Deer Creek is a big reservoir, and if all we knew was Deer Creek, we wouldn't know exactly where to look, especially because these blooms can sometimes be very localized. And so the great thing about this report is we know specifically it's in the Charleston-Dayuse area. You can provide GPS coordinates, that's even better. So when we respond and go to collect samples looking for toxins and specific species information, we know exactly where to head. So please, as you're volunteering, as you might see one of these events, make sure you get both close-up and landscape photos, and you provide really detailed information about site and specific location. And then just one other thing that really helps is please feel free to share what you know. This is an issue that's becoming more and more familiar to the public, but a lot of people still don't know how to recognize a harmful algal bloom. They don't know they can check on habs.utah.gov for conditions. They don't know what appropriate recreational behaviors are if a harmful algal bloom is present. And so sharing your knowledge and your expertise with family, friends, people you meet when you're out monitoring is really powerful to be able to share that good knowledge and enable people to make good decisions. And then last but not least, you can always reach out to me at hbonner@utah.gov if you have questions, if you see something weird, if you want to learn more. We're here to help along with the USU HAB Squad coordinators, and we are so grateful for you and your efforts. Like I've said, we use your reports really actively in our monitoring to decide where to visit, and even reports saying things look good are so helpful because then we know we can prioritize other issues elsewhere. And then when you say things don't look good and provide that detailed information, it allows us to be able to quickly assess and respond to the situation. So again, so much gratitude for your assistance. Don't hesitate to reach out with questions, and happy water watching.